we have a pretty unfriendly looking system of equations that we need to solve. Now, right from the start, this looks different. The kind of systems that we have been dealing with were so far only linear systems. And suddenly we are faced with this. We should have the attitude that if this problem was given to us at this point, that means that at this point we can solve this problem. So let's just simplify things and hope for the best. Maybe this thing is not as bad as it looks like. It's good to number the equations. So let's simplify first the first equation. When the problems are this big, then being organized is becoming an important issue. So if you need to FOIL this out by writing it down twice and FOIL, you should do that on the margin. Eventually, you're not going to need to write this down at all. To square something means write it down twice and multiply. We FOIL, we get x squared. O and I both gives us negative 2x, and then L gives us plus 4, and then we combine O and I, which in case of complete squares always doubles up. And so we can replace x minus 2 squared with x squared minus 4x plus 4. Similarly, y plus 3 squared is going to turn out to be y squared plus 6y plus 9. Okay, so this is already an issue. I didn't leave enough space for myself. So the other side looks slightly simpler. The other side is x squared. Negative y times negative 1 is just plus y. Negative y times negative y is plus y squared. And then we have minus 42. All right, so let's simplify both sides if it's possible. In the left-hand side, there is 4 and 9, right? So we can write x squared minus 4x plus y squared plus 6y plus 13. And the other side, actually, there is nothing to do there. We just rearranged with the quadratic terms first. This equation will become very familiar because x squared and y squared both cancel out. We can subtract x squared from both sides. We can subtract y squared from both sides. And then what we are left with is quite familiar. Negative 4x plus 6y plus 13 equals y minus 42. And so we subtract y from both sides. We get negative 4x plus 5y. Let's subtract that 13. So we get negative 55. So even though the first equation looks really, really scary, after a little bit of algebra, a little bit of a workout in algebra, we get this nice usual linear equation. And maybe that's what's going to happen for us in the second equation as well. Otherwise, we wouldn't get this problem assigned. So the second equation, did you notice that the second sides and the second equations are always simpler? By then the teachers are tired. Just a theory of mine. All right. So the second equation, we FOIL here, x times y is xy, and then we have a negative x and a plus y. And plus 1 times negative 1 is negative 1. And the other side is already as simple as it can. And now the scary part, xy, again, cancels out. So we have negative x plus y equals, let's add this one to both sides, negative 13. So now we're dealing a much friendlier system of equations. The first equation was negative 4x plus 5y equals to negative 55. And the second equation, negative x plus y equals negative 30. And so this system is quite friendly. We can use substitution. For example, for substitution, we can solve for y here. Y would be, after we add x to both sides, y would be x minus 13. So let's do that, actually. So from the second equation, we solve for y. Y is x minus 13. Now, in case of substitution, it's very important that we number the equations, because if the information comes out from the second equation, that information has to go into the other one. So now what we're going to do is we're going to substitute this expression x minus 13 wherever we see y in the other equation, which is equation 1. So negative 4x plus 5y, but instead of y, we're going to write x minus 13, and that's negative 55. And now we have a linear equation in just one unknown, so we're down to really safe ground. We distribute the 5. When we combine like terms, we get x. That's nice. And then when we add 65 to both sides, we get 10. So we got that x is 10. Now in case of substitution, you should circle the substitution because that's where we go back for the other variable. In terms of x, y was x minus 13. Well, y, that is x minus 13, that's 10 minus 13 because now we know that x is 10. So this system solution is 10, negative 3. X is 10 and y is negative 3. If we have time, we should check. We should always go back to the original system. So we shouldn't cross out or mark the original equation in any way. So let's see. So the first equation, the left-hand side, x minus 2 squared is 10 minus 2 is 8. 8 squared is 64. Y plus 3 is 0. So that's easy. 64. So the left-hand side, with these two numbers substituted, turn out to be 64. Now what about the right-hand side? The right-hand side, and so we're substituting here with x being 10 and y is negative 3. X squared is 100 minus y is negative 3 times negative y minus y. When in doubt, just slow down. There are too many minuses here to do a lot of things mentally. Just write. The more we write, the slower we go, the safer it is. So we have minus, that's this minus, y is negative 3, then parenthesis negative 1 minus negative 3, minus 42. These two minuses, that's a plus, and negative 1, to subtract is to add the opposite. So negative 1 plus 3 is just plus 2. So that's 100 plus 6, that's 106, minus 42, which is 64. That's good news because the other side was 64 as well. So the first equation checks. So to check for the second equation, so we're putting the information x is 10, y is negative 3 into the second equation. So the left-hand side, if x is 10, then x plus 1 is 11. If y is negative 3, then y minus 1 is negative 4. So we're talking 11 times negative 4, which is negative 44. Meanwhile, the right-hand side is xy, that's 10 times negative 3, that's negative 30 minus 14, which is also negative 44. So the second equation checks too. So our solution, 10, negative 3, is correct. Thank you for watching.